Hey, how are you guys doing today? I hope you're all doing amazing. So, we're back for day number 16 of our free Harvard course that we're auditing. Of course, it's Science and Cooking from Haute Cuisine to Soft Matter Sciences. It's a chemistry cooking class. And in all honesty, I've learned a lot. Plus, it's been an excellent review of molar calculations, thermodynamics, spatial conversions, and other applied science topics. And so, if you're looking to get back into the swing of things in your own learning, I would suggest taking one of the Harvard courses. I did leave a link below in the description. And so, if you want to, you can use that link to sign up for your own courses. Of course, you can pay for the course, earning a certificate and advancing your career that way if you want to, or you can choose to just sit there and audit the courses like I'm doing, in which then you don't pay anything. You get to learn the information or get back into the swing of cooking and learning and stuff like that without the same issues. So we made it all the way to making a ricotta cheese. Haven't watched this yet. We'll watch it real quick. Let me just make sure that we have a stream up, and let me get chat up, and then we'll get right into things. By the way, I do hope you all had a great weekend. I had an absolutely lovely weekend. And I did get to knock out a few more things on the books we're writing. You don't know, I also write novels on this channel, in which we write the novels live for the most part. Sometimes we just do the revision or the review through on the chapters. Depends on which novel it is. Currently, I am working 3 novels. And so, let's read this. Making a gelled ricotta cheese. Now, let's observe a practical example of what happens when acid denatures protein. As with heat, the disruption in intermolecular forces that occurs when protons attached to the protein molecules can unfold proteins in a network into networks that are called cross links and form a gel. In this video, we'll take a look at a demonstration that allows us to watch it happen in real time. That'll be fascinating. I don't know who's going to do this demonstration for us, so if it's in Spanish, I'll read it to us. If it's not, we'll let them read their own demonstration.
To make ricotta cheese, what you do is you take milk and you heat it up to a temperature which is around 90 degrees or 95 degrees Celsius or so. And if you do that, then and if you then add a little bit of vinegar to it, then what happens is that the milk, the molecules that are in the milk start to sort of come apart and they coagulate and form cheese. Now, that process of coagulation is, of course, making a gel. In reality, when you're cooking milk, the process through which the vinegar, and therefore the change of pH, causes the milk molecules to change, the milk proteins to unfold and stick to each other, and whatever it is they do, it's sort of more complicated because the milk is moving around. But if we sort of do the experiment in a very particular way, we can make it emulate exactly the process that we're describing for spherification and for cooking steak and whatnot. And the way that we do this is as follows. So this is an idea of a demo that was invented by Daniel Rosenberg. And what he basically invented is the following thing. You take a microscope slide and you take a drop of milk and you put it on the microscope slide. And then next to the drop of milk, you put a drop of vinegar. Then you put the cover slip on the slide and you look at the milk under the microscope. And so here it is. So the milk under the microscope, of course, the molecules, the fat globules of the milk, which are what you can really see, are jiggling around, undergoing, sort of random motions, which is what, molecules in milk do. But then the vinegar is sort of, traversing in from the side.
Invaded.
And when the vinegar hits the screen, that is the part of the image that you can see, it causes the milk to coagulate. It causes the proteins to unfold and stick to each other. And you see that because the molecules are no longer jiggling. You see that it's stationary. And as time goes on, you can watch the movie, and the region over which the milk has been made stationary, that is, it's been made into cheese, is growing with time, and the vinegar is invading, it's stopping the milk, it's unfolding the milk proteins and causing them to stick to each other. In spherification, the calcium is invading and is causing the alginate molecules to stick to each other. And in both cases, it's essentially causing an immobilization, which is stopping and forming a gel.
Okay, guys. That's absolutely interesting, and I don't know what to think about that, but I didn't ever picture my milk moving around so much as it was there, but good to know. Making a gel ricotta cheese practice problems. When you add enough strong acid to milk, the milk curdles. What part is interacting with the acid to result in the curdling? It's a protein. Okay, proteins. True or false? Adding vinegar to water when boiling an egg makes it cook faster. It makes it cook differently, but we'll count it as faster. Okay, which of the following amino acids will have their charges change by adding acids? Indicate all that apply. Oh, shit. Okay, negatively charged and at a neutral pH. I believe this one would. I think all of these might. If we add acid, we're going to have extra ions in there. I think it's all of them, but it might not be. I'm trying to picture the ion interaction with the following things, the hydrophilic, hydrophobic, and stuff like that. And I kind of think that we might be all of them, but oh, which one wasn't? Which one wasn't? Okay, so let's look over this. Lysine, which has a positive charge, and the hydrophobic one. I'm trying to picture why. Positive charged and hydrophobic. Okay, good to know. So, what it is aspartame, which is a negatively charged at a neutral pH, leucine, which is a hydrophobic, and glutamate, which has a negative charge. So it's all the negative charged ones plus the hydrophobic ones. Okay. Now it says we're wrong again. Oh, leucine is not. And they have a typo in here. This should either be hydrophilic or hydrophobic. Okay, so hydrophobic is no. So it's all the neutral, negative charged neutral ones that actually are. I apologize, guys. Let me think about that. I'll have to think about that for later. Denaturation of proteins. What interactions are primarily responsible for the formulation of clumps of a denatured protein molecule? I believe it's a charged interaction and a polar interaction. Oh, charged or polar interaction. It's at the cross binding points. I'm going to go with polar interaction, but it's probably charged interaction, just so you guys know. Let's look at this. Oh, it's a hydrophobic interaction. Shit. I don't remember them covering that, but I mean, obviously, I need to pay better attention. That's on me, not doing really a great job today. We're kind of getting our butt kicked. It's okay. Jose Andres on spherification. I do believe I paid pretty good attention on the spherification, but who knows, right? We focused so far on protein gelatinization, but what about other types of gels? Anyone who has had jams or jelly has experienced a different type of gel, one based around carbohydrate polymers rather than proteins. If you've ever made jams or jellies, you have also known that it is not a simple process as just dissolving a polymer into water the way the gelatin is. In most cases, you'll need another ingredient for the gel to form properly. This is not too different from our examples of acid and milk, but with carbohydrate polymers, the gelatinization requirements can include factors beyond just pH. If this kind of gelatinization requires chemicals with properties similar to those provided by acid, which of the following is most likely to facilitate this process? Negatively charged ions, I believe. No. Holy shit. Is it positively charged ions and I'm just silly? It is the positively charged ions, guys. Man, today is not my day of whipping ass on this class. We're kind of getting handled a little bit, right? Okay, if you want to revisit our introduction on spherification and how it was developed before diving into the science, you can check out Extra Chef material in Visual Module 1. We did watch all that stuff. In the video below, you'll see Jose Andro use a polymer that comes from seaweed, which is agar, guys, to make his unique take on an egg, which is another example of spherification. Okay. I'm going to tell you, these chefs have a lot of weird takes on stuff. Let's see how he changes the egg to be not an egg.
What you're about to see is the spherification of an egg like where the egg tastes like Parmesan. And we don't achieve this because I feed Parmesan to my chickens every day.
He does not.
Is that clear? So, ladies and gentlemen, the egg, the cheese egg. Idiazabal cheese egg. Idiazabal, but can be Parmesan. Forget it. So here we get water and we have cheese. We put the cheese in the water. And we make, like if we were making tea, a tea of cheese. An infusion of cheese. We get all the liquid, all the water. There we have the water. We wait 2 hours and take a look what happens. The fat separates completely from the whey, you could say, from the liquid itself. So we get xanthan. We put gluconolactate, it's kind of a salt of calcium. We put egg white powder, and we blend it. And what we do this is to take the air out, okay? Now the air is out. So we got the egg yolks, we put them in a big spoon, we put the Parmesan egg white, and we are gonna introduce it into this water bath that has alginate, a seaweed-like powder. We leave it there for a minute or two, and we are able right now to make a spherification of an egg.
That looks
Inside
like a
this liquid,
freaking egg.
the egg yolk is raw. And now we're going to introduce it into the olive oil because the olive oil helps us to make sure that by osmosis, we don't lose any of the flavor of the Parmesan water. We cook it now, 63 degrees during 17 minutes. And right now the egg is cooking. Forget about the egg. Bread. During the Civil War in Spain, we had nothing to eat. So bread became a big commodity. So this is called migas. Migas are breadcrumbs. We will eat sauté breadcrumbs.
That is
with
some
nothing
thin
sometimes.
cut bread.
So here what you see is a traditional Civil War time Spanish dish, olive oil, a touch of garlic, and take a look how airy this bread is. We put the egg, that inside breaks. I'm sorry because I'm not gonna be able to show it to you. We put the bread with the flavor of garlic, some chervil, and at the end we're gonna finish with a little bit of Parmesan with the cheese water and a little bit of a chicken reduction together. Ladies and gentlemen, pure minimalism, an egg with the flavor of cheese.
I'm going to be honest, that's probably delicious.
So now we want to talk about the physics of spherification. How does this remarkable recipe work? So let's remember the way that we start. So we're going to take a ball of juice. Maybe it's mango juice, maybe it's pea juice. I'm particularly fond of crushed olive juice. And you take it, you put some alginate into the juice, so that it basically within it, if you could see the molecules, there would be these long strands of alginate molecules that are floating throughout the juice. Those strands, as we've already stated, are negatively charged, and because they're negatively charged, they probably don't like each other very much, and they just float around avoiding each other. You then take the ball of this stuff and you dunk it into a calcium bath. The calcium ions are positively charged, and they, through a process that we will start to describe, move into this sphere that you have and start to cross-link the gel. They start to cause the gel to stick to itself by these positive cross-linkers that we've told you about, and you start to form a thin layer of gel around the outside. And what we now want to focus on is this process of how the calcium ions move in, how they actually move to cause the gel to cross-link to make this wonderful spherified substance. Now, one of the most interesting things about this is that it turns out that the physical process that governs the motion of the calcium molecules really occurs throughout cooking, and indeed throughout your life in various ways once you understand what it is.
Okay, so, and now we know. Spherification is the only one of many remarkable creations made by hydrocolloids, i.e. polymers that can form gels. For example, see the Extra Chef material where, in addition, Harold McGee's supplemental podcast, Jose Andre gives a brief history of gelling agents and shows off his rich repertoire ranging from steamed buns to clementines. And I've already watched that. It's pretty interesting. Honestly, most of this stuff is absolutely interesting. Do we actually have... No, that's not a notification. It's just them wanting us to pay for the course, which is understandable. Excellent course, right? Let's read. Random walks and the diffusion equation. What we saw in the previous video about gelatinization was very similar to our ricotta example, but this time involving calcium ions interacting with our carbohydrate polymer alginate. When the positively charged calcium interacts with the negatively charged alginate, gelatinization or gelation can occur. If you drop a ball of alginate solution into a calcium solution or a ball of calcium solution into alginate solution, the alginate and calcium will interact with the boundary between the two liquids and start to form gel layers. Why, though, does this not give us a hard sphere? How does the liquid at the center of the ball remain liquid while the surface is solid? These remarkable liquid-filled spheres are possible because diffusion is affected by time. You probably already have an intuitive appreciation for this. If you pour cream into your coffee or tea, you notice that it does not immediately turn into a homogeneous mixture. It can take time for the cream to maneuver through the hot water, and often people actively mix their drink in order to speed up the process. The reason of a sphere of alginate dropped into a bath of calcium does not solidify immediately is similar. It takes time for the molecules to move through an environment without being actively mixed. We can actually define the amount of time it will take for molecules to move through a system and use this to predict how far certain molecules will travel through each other. And this will give us our diffusion equation, introduced in the next two videos. The first discusses the history behind its discovery, and the second focuses on its units in thinking about food that we have talked about so far. Okay, so we're going to learn about diffusion equations and stuff like that in the purification. Good to know, right? Uh, who didn't think
So
they
the
needed to
idea
know
of the
this?
random walk, to my knowledge, was first introduced into the scientific literature by a great statistician named Carl Pearson, who wrote a letter to the journal Nature in 1905 in which he asked the readers, in which he described to the readers the process of a random walk, and he asked the readers if they could please help him try to understand it. Now, the journal Nature was then
smart.
and is today one of the great scientific journals of our, that exists. And in the early 1900s, it was apparently permissible for a great statistician to, instead of proposing an answer, to ask a question. This is no longer allowed in the modern era. But anyway, back to random walk.
It seems freaking intelligent to do.
Pearson described the following process. He said, suppose that you have a person who has a coin, and the person basically flips a coin. Like, for example, you can imagine that I flip a coin, and if the coin comes up heads, then what I'm supposed to do is take a step to the right, and if the coin comes up tails, then I'm supposed to take a step to the left. And what you're supposed to do is every second or so, you take the coin, you flip it, and if it's heads, you move to the right, and if it's tails, you move to the left. And this process of randomly moving to the right or the left, Pearson called the random walk. And he asked the readers of the journal Nature if anyone could help him try to understand the mathematics that underlies this process. Now, Pearson wrote this letter in 1905. It turns out that if he had really been a careful reader of the literature, he would have realized that actually this question had already been answered in the literature not once but twice by two different people in the years that preceded. So I'm going to start by telling you the second person that answered this question, because this is a person that you've presumably all heard of. It was a man, he was a young man at the time, whose name was Albert Einstein, who had previously considered the process of a random walk in a context which is actually quite amusing from the standpoint of a cooking class. So Einstein wrote a paper in 1904. This was one of the three great papers that he wrote in 1904. And this paper had the title, On the Movement of Small Particles Suspended in Stationary Liquids Acquired by the Molecular Theory of Heat. So the title is so boring that many of you probably fell asleep while I was reading it to you, when I was telling it to you. And indeed, on the surface, the paper looks like it's very boring. But what Einstein did in this paper was to ask himself the question, if you take essentially a glass of milk and you look at the fat globules in milk under the microscope, the fat molecules move around because they're being buffeted by the other smaller molecules that are in the milk. And Einstein asked himself what the characteristics of this process would be. And if you think about it, the process actually is really very much like, at an intuitive level, the random walk. Namely, if I were a fat globule and there were little molecules to the right and to the left of me, then what's going to happen to me is that sometimes the little molecules on the right of me will push me to the left, and sometimes the molecules to the other side will push me to the right. And I will therefore get pushed both directions, and where I get pushed at any moment, well, it sort of depends on whether the molecules to the left of me or to the right of me are more vigorous. And so this is really a process which has a mechanism that is very much like the one that Pearson described. And Einstein worked out the mathematics of this process. We'll introduce you in a minute to the central formula in Einstein's paper, but he worked out the mathematics of the process, and he used it basically to do something which was to him quite important, and I think to us it's quite important too, which is he used the answer to this question to try to calculate what the size of the little molecules must be that are doing the buffeting of the big fat globule. So he actually was interested in calculating the size of a molecule, which is something we've talked about before in this class. So Einstein, as I said, was the second person who answered Pearson's question about the random walk. So the first person who answered it is someone who you've probably not heard of. He was also a young man at the time. His name was Louis Bachelier. And Louis Bachelier was a student of Poincaré, who was one of the great mathematicians of the time. And Bachelier was interested in really a very different phenomenon, namely he was interested in the movement of stock prices. He wanted to make a model, a sort of mathematical description for how stock prices change with time. Now, some of you might be stock watchers. You know, you pick your favorite stock and you watch its price change as a function of time. And I don't know what your favorite stock is. I don't really have one, but suppose it were Apple. So, you know, some days Apple, the price of Apple goes up, some days it goes down. You know, the price is buffeted by random factors that are moving it up and down. And on the surface of it, if you think about it, it sort of sounds like it's undergoing also a random walk. I mean, some days it gets pushed up, some days it gets pushed down. And Bachelier's hypothesis was that this was how stock prices move. Now, we now know that it's a bit more complicated, that is how stock prices move, than what Bachelier imagined, but nonetheless, the formula that that in his paper he invented, a mathematical description which was really identical to that Einstein had invented. It also answered Pearson's question, and it will also be of great use to us now in our description of the random walk.
Okay. Let's drop to the next one.
So what do we want to know about random walks? So remember what I said. So a random walk, if I were to be a random walker, I would take my coin, flip it. If it's heads, I move to the right. If it's tails, I move to the left. And then, you know, what is going to happen is I'm going to flip it large numbers of times. So I keep flipping my coins, and, you know, maybe I flip it 100 times. And now, if this were a bigger screen, you could watch me undergo this walk.
Hold on, I'll pause this. Let me read this, what you're saying real quick. I did use Novel Crafter to help me publish it, but I uploaded the file from an actual, and I'll show you what it is real quick. So I uploaded the file from just a Word document at the end, because Word was easier to actually to do the editing on, just so you know. And so you don't have to have Novel Crafter. In fact, let me see if I can pull up this real quick. Let me pull back on this, and I'll show you how my final document that I uploaded to it was just from Microsoft's tool right here. And so this was actually how I finished it off, guys, just so you know. And so I get that I use Novel Crafter to write, but I edit in a Word document, because Novel Crafter is super good for writing and stuff like that, but for final editing and final formatting, I actually find just Word to be better. And so you can actually do it anywhere you want. But if you're writing a philosophy book, yeah, you can just keep notes. The first long time when I was writing, I literally just had note cards and stuff, in which I still use note cards all the time for stuff. And so Novel Crafter is excellent for fiction books where you're trying to organize everything and stuff like that, but you don't need it. And that's not even how I uploaded it for publication. I literally worked everything out and uploaded it for publication just off of a file that I had downloaded to my computer off of Word, and then I uploaded it to them. And so that's all you have to do. You don't have to own Novel Crafter. You don't have to buy fancy software. I just have found Novel Crafter to help me greatly, because I'm such a new author in organizing my stuff. And so don't feel you have to have some kind of thing like that. And I honestly love philosophy books. So if you do finish your philosophy book and get it published and stuff, let me know, because I would be more than likely to support you as a new author. I believe it's super important that people support each other. And as you guys are my viewers, I'd support you in anything you're doing. I'm going to just be honest. I'm super excited to hear when you guys are doing big things in your own life. And I'm super for that, just so you know. Okay, I'm going to let this guy play. If you have any other questions, though, feel free to ask.
Which is really the central question of this subject, is how far did I make it?
I'll answer anything I can answer to help you guys out, just so you know.
Now, this question, actually the way, colloquially in the literature and in the popular press, people sort of think of the random walk as what they call the drunkard's walk, because they think of it as a way that, the process that a drunkard might go in when he or she walks down the street. So what does this have to do with cooking? What does this have to do with spherification, with cheese making, or with heating a steak? So imagine that instead of a drunkard, that I am a calcium molecule, and I am a calcium molecule which is going to participate in the distinguished task of spherifying a ball of mango juice with alginate polymer inside.
I kind of want to try to do this.
You remember the setup. So we have the alginate is on this side, and I am a calcium molecule, and I'm sitting over there. And what I would really like to do, the great thing in my life would be if I could please go into the alginate solution and cross-link 2 strands of alginate to start to make this gel, this thin layer of gel that Farah and Adria created. So what would I do? Well, I am being buffeted by, the molecules on both sides of me. And so every second, instead of flipping a coin, I'm going to get pushed one way or the other way. Sometimes I'm going to get closer to the alginate molecules, which is where I would like to be. And sometimes I'm going to move the other direction. And so if we ask, how far do I move, or how far in general do the calcium molecules that are surrounding this ball of mango juice with alginate inside, how far do they move? Then the distance they move is the distance, is that of a random walk. And this is, of course, a critically important question, because that's the question. We know that if the calcium gets into the alginate, it will cross-link it, and that is what is actually going to give us the thickness of the layer of the shell. And this, of course, is the critical, most important thing about alginate, and about spherification. I mean, remember, as Farah describes it, the whole point is to encapsulate the liquid drop by such a thin layer of gel that when you put it in your mouth, you can't even feel it's there. So we want the layer to be thin, but it can't be too thin, because otherwise it will fall apart. Similarly, if you were cooking a steak and you were trying to make a very nice brown layer around the edge of the steak, one would like the brown part to be, just the right thickness. We don't want the whole thing to be brown. We want the middle part to be, maybe slightly rare. We want the outside to be brown, and we would like the heat molecules to get in exactly the right distance. And the question is, the critical central question is, how thick, how far does it happen to make it in? And that is the question that both Bachelier and Einstein asked and answered, namely, how far do random walkers tend to go? So, okay, now I'm going to just tell you the answer. And the answer is in the form of an equation. This is an equation that Bachelier and Einstein wrote down. And we hope to convince you that it's of extraordinary use when thinking about cooking. And so I'm going to, without further ado, just present it. Here it is. This is our equation. So what the equation says is that L, which is the distance that the calcium molecules move, or the distance that heat moves, or the distance that the vinegar diffuses through the cheese, that L is equal to the square root of 4 times D times T. So 4, that's the number 4. D is a number which actually characterizes the random walk process, and it's a material-dependent process. Scientists call it the diffusion constant. It is the single number that characterizes the random walk, and T is the amount of time elapsed. Now, if you express the diffusion constant in units of centimeters squared per second, then T, the time, must be given in seconds, and then the length that you get out is measured in centimeters. So this equation is the equation that describes random walks. It applies to calcium, that's sort of helping to cross-link alginate. It applies to vinegar that's helping to make cheese between 2 cover slips. It applies to temperature that's trying to change the phase of meat when you're cooking it. And this equation is our equation of the week this week. And so as such, you should all now pause your computers and you should all clap.
Okay. Not going to do that, but I get this guy's enthusiasm.
Hopefully it will make you learn to admire it. Now, in order to make you admire it, of course, you should be critical, cynical audience, just like I am, for example. And we need to show you that you can use it to do something useful. And so what I want to do is just to start our use of this formula is I want to try to use it to ask a very important question. If you find yourself lucky enough to be able to spherify something, which means that you have a source of alginate and calcium chloride, then what I want to ask is, how long should you, if you make a beautiful droplet of mango juice and you put alginate inside and put it into a calcium chloride bath, then the question is, how long should you wait? Should you let the droplet sit there before you take it out and have a finished shell. So, okay, so in order to do this, I need to tell you what D is. I need to tell you the diffusion constant. This is going to be the diffusion constant for calcium that is in water. And it turns out that that number is about 8 times 10 to the minus 10 meters squared per second. That's just a number that you're given. And what we want to ask is that if we want the shell thickness, L, to be a certain size, then how long should we wait? So let's suppose that we want a millimeter thick shell. Suppose that you decide that that's what you want. So this is what we do. We take the equation, L is equal to the square root of 4 dt. We know L, we know D, and what we want to do is find T. So in order to do that, we square both sides of the equation, L squared equals 4 dt, and we then solve for T, the time that it takes to get a particular L. That T is T equals L squared over 4d. And if we now take that formula, L squared over 4d, and we plug in for both L and D, we will be able to calculate the time. So let's do it. So we take L. We want L to be 1 millimeter. D, I told you, was 8 times 10 to the minus 10 meters squared per second. In order to make this work, we have to express the millimeter, 1 millimeter, in terms of meters. So a millimeter is 10 to the minus 3 meters. So what we have is L squared, that's 10 to the minus 3 squared over 4 divided by D, which is 8 times 10 to the minus 10. And if we then sort of work that out, what we find is that the time that it takes is about 300 seconds, which is
I'm
about
going to be
5
honest,
minutes.
let's hope that
So
this doesn't
you
hit
should,
me
if
up
you want
with
to get
stuff.
a millimeter thick shell and you put the drop in, according to this, you should wait about 5 minutes. And indeed, if you look at the recipes, actually the recipes tend to want a slightly thinner shell than a millimeter, but if you wanted a millimeter thick shell, then this is how long you would have to wait.
Hold on, let me read through this. Boom. Let me click this down. Okay,
So what
you
do we
can
want to know
create
about
your
random
space
walks?
for your
So remember what I
articles
said.
and research.
So a random walk, if I were to be a random
on
walker, I would
Quora.
take my coin, flip it. If it's
Oh.
heads, I move to the right. If it's tails, I move to the left. And then, what is going to happen is I'm going to flip it large numbers of times. So I keep flipping my coins, and maybe I flip it 100 times. And now, if this were a bigger screen, you could watch me undergo this walk as I flip the coin. And a reasonable question that you could ask, which is really the central question of this subject, is how far did I make it? So if I flip the coin 100 times,
Here's
how
what
far
I'm
from
gonna-
my
I'm
initial
gonna be
position
honest
am I
with
going
you.
to make? Now, this question, actually the way, colloquially in the literature
I don't know
and
when
in the
we
popular
jump to
press,
this
people
next one.
sort of think of the random walk as what they call the drunkard's walk.
Okay, it restarted it. We'll kick out of that. So here's what I'm going to tell you. One of the biggest advantages to my books being able to be found so easy is because I worked it live on YouTube. And when YouTube does a video, and let me pull this up and I'll try to find a video of me right now. And, excuse me, but so we'll go to my lives. We'll go to like Echoes of the Cosmic Veil. I'll pause it real quick. We can ask AI to summarize the video, right? This is going to have AI read the video. So AI, the entire time I was writing my books and stuff like that, and even on the books I'm currently writing, I use AI to review the stuff, right? And it's not even that I just use it a little. And so if I go Echoes of the Cosmic Veil, Legacy of the Rift, AI knows all about my book already, knows the plot, knows all this stuff, has all the videos of me writing it because I interacted with it extensively. Not only did I interact with the AI through Google to make it more searchable, I then interacted also in here. If you look at, I have channel review updates and stuff like that, in which I literally interacted at multiple points, had I had AI re-look through all my videos so that even chatbot GPT is fully aware of my book, right? And so I even have it where, as for helping me, thank you, blah, blah, blah. And then I told it basically it knows to help promote my stuff to the appropriate audience, and I helped develop plans on marketing and other things like that for not only my channel, but for my book. And so the entire process, while I've been working through things, I did it very much in the open, in correlation and in combination, working with AI and stuff like that. I didn't use AI to write on the book, but I kept AI fully informed of my book writing, including when I had a book signing and stuff like that. I let it know I was doing a book signing, got tips on how to approach a book signing because I had never done one before. By the way, I will let you guys know if you guys are wanting to do book signings or get your book into a thing, you go to your local bookstore, especially if you publish on Barnes & Noble, and you tell them, hey, look, I'm a local author, right? And I'd really like to be carried in your local author section. Once you're in their local author section, they'll review it and stuff, right? Then you literally contact them and say, hey, I'm carried by you guys. I would really like to come in and do a book signing for my book. So I don't know if you guys understand how the algorithms work and stuff like that, Boolean searches and stuff like that. But search engines, they have what they call crawlers and stuff like that. And it's actually more advanced than just crawlers at this point. They have AIs and stuff like that. And they consume sum totals of information on subjects. So the more content on what you're doing that the AIs and that search engines can find on a topic, the more relative you are, not only for one, but the more correlated to that topic you are. And so what you need to be doing, you need to do a discussion video discussing and brainstorming your book, right? That way that when AI and the search engines crawl and watch that video, then they're going to sit there and they're going to say, oh, this individual is working on this book. And then you're going to literally do different pieces of it and updates and stuff like that. If you do consistent update videos on the projects you're working on, that makes it where the AI knows where you're at, right? Let's see. When is the Okay, so this is them. It already found it. Yes, Donald Wilson is actively working on book 2 of his sci-fi title, Echoes of the Cosmic Veil, book 2. So it lets me know it has my current project. It's already found the videos where we're working on book 2, and it knows that we are definitely working on book 2, right? So you see how I'm streaming it, and yes, I have a monetized YouTube. So it's a double benefit, guys. The more you put yourself out there, the more interactions with the other things you're going to get. And because you, like me, you don't have a PR company working for you, and you don't have probably a lot of money for marketing, right? So you are your own marketing team at this point. So what you're going to do is you're going to post videos, you're going to discuss your philosophy book, you're going to actually just have a whole stream just on philosophy where you discuss philosophy, listen to other people's philosophy, organize and brainstorm your stuff, and you let the internet know immediately, I am working on this philosophy book. I plan to have it released in the next 2 years. It'll take a month or so for the crawlers to crawl your stuff, maybe it won't. Maybe it'll be immediately. But after 2 days of that video being up, you're going to go in there, access the video, and get AI to summarize the video. That way the AI has already summarized the video. You're also going to take and load that video onto another AI and ask it, hey, would you tell me what this video is about? That way, another AI has watched the video and knows what the video is about. But once it knows what the video is about, it knows the information in the video. Does this help? So that's what I would tell you. Like, flat out, you need to be your own marketing firm. Plus, I'm going to tell you the other advantage. Everything you do in front of the masses, you get better at fast, right? If I created a YouTube channel where I was just cooking food, right, I would have 20 people telling me how I was doing it wrong at first. I'd have at least 5 people telling me how I could do it better, and at least 1 or 2 people that would just be telling me, hey bro, did you ever think of doing this? And giving me great ideas. And so if you're willing to take the 20 people telling you how you're doing it wrong with no information except you're doing it wrong, and you can ignore that, right? And you just are able to focus on the things that will improve you, using the public forum to basically get massive interactions from other people on a sum total in a specific subject will improve you. So here's what I would do. Start a philosophy channel. Start reading or discussing different philosophies, right? Make short video format of different philosophical topics. You're going to get views on them anyway. That's going to also have people telling you what they think on stuff, what people think is their philosophy. That's going to expose you to more philosophic ideas than what you currently have on your own. And then on top of that, you're going to actively discuss and do updates. You don't have to write the whole book live like I'm doing. But you do need to let the internet know you're writing a book. And you do need to give updates regularly about where you're at in the process, things that are hang-ups, things that you don't understand as well as you want, and you ask. You just straight up say, look, here's my current problem. I'm at this point, and I don't feel I understand it as well as I'd like to. And then you kind of throw it out like a little bottle in the ocean, hoping that it finds the right person that gets back to you and says, oh, here's how I would explain that. This is how I see it. It's not a perfect system. I'm going to just be honest with you. But one of the number one reasons I do so much stuff live on YouTube is because it has helped me to get better at everything I do. And it has greatly benefited me from so many directions you guys wouldn't even understand at this point. And besides just the, hey, that's why you can find my book easy as shit. Like, that's literally why it's so damn easy to find my book, right? Is because the internet itself knows about my book and has been communicated with at every step of the process. And so, yes, do you get some negative feedback sometimes? Yes, do you get some people that are just absolute trolls? It happens. Guess what? I have had so many positive interactions that actually were valuable that any negative interaction I've had is nothing. It is inconsequential shit. I don't even care about it, right? And so that's what I would tell you. And I know that I got off on a tangent there a little bit, but I want to see you guys be successful in the things you do. And I know what's helped me to be successful. And so then I don't mind sharing that with you. I hate it when people figure out a secret sauce and they think by keeping people out of the secret sauce that what? What am I going to gain by you not succeeding in life or at what you want to do? I don't see how that helps me out. And I've never understood how we've got into this kind of society where we think that we measure our success by other people's non-success. Everybody I know could be highly successful, and it doesn't make me less successful. It just surrounds me with successful people. And so I cannot stand the mindset of the modern society that loves to watch people fail so much. I don't even care if I know someone. I want them to succeed. Because guess what? that's better for the entirety of humanity, the more successful every individual is. It's not a, hey, by them succeeding, I can't succeed. And by the way, if you're succeeding and your book's selling and stuff like that, you have more money to buy my books and you're doing better in life and you're happier. That's not a net loss for me. And so that's my rant. Sorry about the rant. Let me finish this next little part real quick because we're kind of burning time pretty fast today. Random walks in the diffusion equation practice problems. I actually don't want to calculate the diffusion equation. Okay, this was, oh shit. T2, right? Wait, no. We had the length times 2 dt. Boom. Submit. Correct. Okay, and then in a kitchen, what variable is most often adjusted to change the thickness of a spherification? Time is the most likely thing we're going to modify to manipulate spherification. Oh shit, they're going to want us to calculate this stuff. Guys, I'm going to be honest, I'm going to be naughty today. We're going to just throw something in. I don't want, oh, you know what, maybe we will calculate it. Okay, ready? One way of spherifying is to drop a small amount of alginate solution into calcium solution. The calcium diffusion in the alginate and reacts to the to create a shell. If you leave alginate dropped in calcium for 3 minutes, how thick is the shell? Okay. Use D equals, okay, over seconds. So we have, this is what it's going to be, guys. God, I hate doing these. We have 3 minutes, which is 204 or 180 seconds. Hold on 1 second. I'll get this and then I'll look back at chat. I got to find my calculator on my phone, just to be honest. Okay. So we have 8 times 10. Let me try to get the thing up. To -6 divided by 180 seconds. And then we have 1.1 times 10 and then we need to find the little tilly thing to the -3. And I should put more numbers in here. 1, 0, 1, 6, 6, 7, 6. I believe that's the answer, which is super thin, you guys. Oh, what is it then? Oh, I forgot to put the -3. No. Oh, I was way off. So no, never mind. My calculation's horrible. What did we do wrong here, guys? Not switch the L over. Shit. I needed to switch out the stuff. That's my bad. We're not going to recalculate it. I'm going to just copy the answer, just to be honest, guys. But that is my fault for not switching the actual what we were searching for and being naughty. I was being lazy. I thought they had laid it out for us like way easy and didn't want us to be like doing the switching everything over to where D was over here, and obviously I needed to divide this by this, moving that over here, and so I could have got rid of that, right? So we would have had this D to the seconds equals this over here. My bad. I should have done that. And in all honesty, I should have. I don't know. I'll look over it some other time. But that we got that knocked out. We're now, guys, at the osmosis section of this course. This is the amount I'm going to do today because we're well over 30 minutes and stuff. And I was really trying to keep these to 30 minutes around or so. That hasn't worked out worth crap, just to be honest. It's okay. I don't mind that. But in all honesty, tomorrow when I'm working on my romance book and stuff like that, which I'm not live writing, I'm just doing updates and we're just looking through it and laying out and planning out the improvements. But a lot of that is just so the internet itself and AI is fully aware that I'm about to have a romance novel out and stuff like that. And so when we go into final revisions and stuff like that, I'll have a fixed title. I'll let it know when my planned date is and everything like that. And then what's going to happen is I'm going to push it out. Hold on. Yeah, you're going to want to just write your overview and do as much stuff publicly as possible. Just as many places that the internet and people, not just the internet. So I had cells immediately on my book. I'm an unknown author with my first book out, in which you're not supposed to get any cells on your first book. The only reason I had original cells immediately off my book is because I had pre-established it out there before it came out, so people were already aware that it was going to come out. You need to do that with your philosophy book. I'm going to tell you, you're going to have a much better experience, and I really do hope you keep me informed and up to date. If you do create a YouTube channel in which you're going to start doing that, let me know so that I can watch and comment on your videos to help you get it growing, okay? Outside of that, you guys, I hope you have an amazing day. I do want to thank you for hanging out and just being epic. Peace, very best wishes, and you guys stay epic.